Yeah, so today I want to give you such a brief video for explaining my project's code. And my project is for like finance AI. So our team is making such a software for predicting the stock price, and that model is really useful because we use like the machine learning stuff. And okay, due to the time, I just gonna go into my code to explain something. It might take like 5 minutes. So the first firstly I'm using the Jupyter notebook, and because it will show me like the output for each cell input is really visualized. And for the first cell, I import every module for what I gonna use below. And yeah, the second one I gonna call the like reading the file, the combined stock data. So combined stock data is the file like was modified by the original file the computers the organization give me. And it has something more like five more features. They are subjectivity, objectivity, positive, neutral, and negative. The algorithm for writing this file is right there, and it was referenced by a programmer in GitHub, and I modified the file for like I can rewrite my original IDJA file into this file. So it's really useful. It's a thing. And that is, I just show the header to make sure that it's file I want, and show the data frame, the shape of data frame, the data type. And then I call the DJIA table, which contains like the open price, highest price, those features. And then what I did is like combine these two files in the same table for like, so you can just do some operations in this file to get some useful information like prediction. And then I merge the data file as what I said, merge them and then describe them. Then you can see like some basic information there, like the main of those columns, those features, and show the histogram. So the histogram is basically from the 2008 year to the 2016 years. They show like the changing by the time passing for each feature. Like the adjust close is increasing until the mid and then going down quickly and then increase. Okay, then I wrote down such a scatter for the user to analyze this. Exactly, we don't really need that part, but it would be useful to visualize those graph, right? And I found some NaH value in the dataset, so I just like visualize them using the merge, like the heat map, to see okay which part of dataset is missing, and they show us the middle of it, and that is why we could like increase our accuracy of the model. So in the next part, I gonna call the heat map method to get a heat map graph to see the relationship between those features. Like for example, the label, the subjectivity is has 0.01 relationship. It's quite low that we can like ignore it. It's just a thing, and yeah, and we can count down all this relationship between to see their negative 1 0 basically affect the prediction or not. And then in the next part I gonna show you like okay, so we are planning to train the data into several different models like LR, LDA, KNN. All these models are machine learning based model, and they're quite useful. But I wanna say we can only choose one because nested model is quite complicated. So I took like one of them, the highest accuracy one, because I was basically like testing the accuracy of each model there, and then they show me something like, okay, the LDA showed me an obvious output, and for that I try to prepare the model LDA. First, just scale them, transfer them, pre-processing the data, and then fit in the model to get the accuracy of the score, the confusion matrix, all this evaluation, and then like generating the ROC curve to see the true positive and the false positive, make sure this model is as much accurate as we want. And then after all this stuff, we will need to like upgrade our model. So what I'm doing there is like selecting the feature importance for some model. Like I choose two models there, algorithm maybe XGBoost and random forest. They're they're quite like they're quite apparently very good, and they all give us similar output result. Like low, neutral, close are the most first three important feature for prediction, because in this model they're basically computing like the weighted what kind of feature affect a lot. And you can see the graph there, they are basically returning the same stuff like the neutral, close, and volume. So finally, our team would like to choose the XGBoost because it's the most accurate one, and then we fit the data into the XGB classifier. It's basically a machine learning classifier, and we got the score like in the sorry, in the estimator to choose the optimum selection. And then okay, there is something like I'm using an outdate module method, and it returned me so many warning, but yeah, it doesn't really affect the final result. So I got those features. I finished this optimum choosing like the estimators, and then get the final score and below the optimum selection. And then I found like, because basically we choose three factors and we want to do the PCA transformation because there are so many features in there, and some of them are useless for the prediction. So just do the PCA, choose like n components as three, the three most important one, and fit the data in the PCA transformation. That is what we want, and we got such a good output. Like it is done as 94%. It is the same as someone did in the GitHub, but yeah, we got the same result, like 94%. It's really good. The confusion matrix is showing like the similar number in there, and then it's cool. We finally generated the ROC curve to see the first class error and the twice class error is optimizing show. So it's very good. And then in the last stage we use like time series split it into three part of data, because we want to do the prediction data we're gonna get as a time series, so we cannot just consider them uncontinuously, so they should be continuous. We showed like the time split, you see there are like three parts there. Is changing a lot. The observation is not constant, but yeah, observation is not constant, but it's like changing a little bit by each time stage. And then for the model LDA, the previous, not previous, the first one we choose, we report the accuracy, and for the random forest, so random forest classifier, we report the accuracy, and but it's not so good as the RGBoost classifier, and yeah, XGBoost, sorry, and that is not the part of the code I want to delete it. And so at last, I firstly visualize the data from the closing price of the stock from 2008 to 2016, such a graph. This is from the original data, so it's not including machine learning stuff yet, and just want to like do a comparison, because later I will show you a new graph and I use so much time. So finally I built such a ARIMA model. ARIMA model is precisely for like common model for predictioning time series data set, and by looking the plots I wrote down two functions. They're basically like finding the best combination of PDQ, those hyperparameters. And it's really hard work. It takes my machine a lot of time, so I don't want to show it again at now because I only have several minutes for this video. And then at last I can show you like my final prediction for the code. It's like, okay, so I predict a lot of numbers that is from the beginning of the data points to the last data point. Like, okay, for this value is 7949. So this is the just closing value for the current day. Like the data point was given in the table. I can show you quickly there, and it is not there, but yeah, this is the closing data at the 2016, and that is the predicted number. So that is my conclusion, like the price of the stock is decreasing, and the testing MSE based on the ARIMA model is 2795, and that is the prediction graph of the that is the graph for prediction finally. And that is my explanation and implementation. Thanks for listening and watching.